Hey class, Mr. Mohidian here with a example of one of the problems from our practice assessment in preparation for our test on implicit derivatives and some other skills. This is actually an AP question that I've taken from multiple choice but made it here open for your response. So let's take a look. We're asked to find the slope of the tangent line where x is equal to -1. So right away you know that this is an implicitly defined function, so we're going to need to use some implicit differentiation. So I'm going to apply the derivative operator to both sides of my equation. So the left-hand side and the right-hand side are both going to become, I'm taking the derivative or the change with respect to x to give me the slope. So on the left-hand side, I literally have dy dx, so dy dx. On the right-hand side, I have a lot more. Let me focus on these two parts at first to get those out of the way. So it leaves me some space here, and I'm going to write plus 2x plus 0. Now notice that was just plain old 2x because we have a match in our variable of differentiation and our variable of our function. So when everything matches, then there's, so everything's nice and easy. X squared becomes 2x. Here's where things are more complicated. We have two functions there. We have x and we have y. So, and they're being multiplied, so we're going to use our old friend, the product rule. So let me list out my ingredients here. F I'm going to call x, and f prime, the derivative with respect to x, is literally just 1. G I'm calling y, and g prime is the change of y, or literally dy dx. So toss them in the product rule, so f prime, which is 1, times g, plus f, which is x, times g prime, which is dy dx, and then the other parts are already there. My goal, or at least one of my goals, is to have dy dx solved for. So in a sense, you can think of this as one large variable. Again, it's not really a variable, but in a sense, think of it as a term that you want to isolate. So let's gather them all on the same side. So I'm going to move this chunk over here by subtracting it from both sides. So minus x dy dx from there. And over here, minus x dy dx. These are not like terms, so I have, try to keep this color-coded, dy dx minus x dy dx, and on the other side I have a bunch of junk already there. So we'll just make that in black since it's kind of already part of the problem. So I have 1y plus 2x, okay, plus 0 went away. So here's where sometimes people get stuck. Let me just give you an observation that a lot of problems of this type of implicit differentiation come to this step, where you have multiple dy dx's or y primes, whatever you want to call them, and you have to kind of solve for that variable. So to do that, simply factor out dy dx from both terms. So I'm literally extracting this out and extracting that out. So dy dx would leave me 1 here minus x. And if you're ever not sure about factoring, remember you can just distribute, and if you get what you started with, then in the previous step, then you know everything worked out okay. Is equal to y plus 2x. I'm going to divide both sides, because that's the opposite of multiplication, by 1 minus x. So the slope, the derivative, the rate of change of this function is y plus 2x over 1 minus x. Now, in many problems, in fact, in the other problem on the practice assessment, this is a sufficient answer. It asks for dy dx, but notice this one asks for the slope where x is equal to -1. So it wants a numerical answer. So keep in mind that x is going to equal -1, so right away we know that this is going to become -1 and this is going to become -1, but we also have this pesky y here. So really, before we even started, although you may not have realized this at the time, we need to find y. In fact, you can find y before you do all of that. So let me kind of do this here in the corner. My original function was, if I recall, y equals xy plus x squared plus 1. The question is, what is y? Because we need that in order to plug it into dy dx. Well, x is equal to -1, right? So just plug -1 in wherever you have an x into the original function to find y, the way you ever would to find an output when you have an input. So y, we don't know. Well, this letter y, why is because it was asked for. X is -1, so -1 times y plus x is -1 squared plus 1 is the problem there. So y equals negative y, negative 1 squared, is 1 plus 1, famously known as 2. Add y to both sides, so I have 2y is equal to 2, divide, and you have y equals 1. So what this means is we inputted negative 1, and our output is 1. So there's our x and our y. So again, you can see that that's pre-calculus. We could have done that at the very beginning if we wanted to, although maybe you didn't realize it until now, although you might want to, just to avoid forgetting that step. So now combining these two pieces of information, we have the slope of this function at the point negative 1, 1, where we're given half of that, we need to find the other half, is equal to, well, it says y, which is 1, right, plus 2x, plus 2 times, well, x is negative 1, over 1 minus x, so 1 minus negative 1. So 1 minus negative 1 is 1 plus 1, again famously 2. 1 minus 2 on top, which is negative 1, so we get a final answer of negative 1/2. So that means this function originally given to us is decreasing at a rate of change of negative 1/2 at the point negative 1, 1. All right, hope this helps.